So in today's class, we are going to learn about the next concept in pointers. We already learned in the last class what actually a pointer is and how to declare a pointer and how to display the address of a point, address and value of a variable using a pointer variable. All these things we have covered in the last class. I hope you all are clear with those concepts. I told like I'll define once again a pointer. What actually a pointer is? Pointer is nothing but we learned in the last class like it is like a normal variable only, but it will be holding the value like the value will be the address of another variable. So pointer is nothing but a normal variable which will be holding the address of another variable. We can't store directly a value into a pointer. We can only store the address of another variable, and how that can be done. All these things we have learned in the last class. Whenever you want to declare any pointer, you need to differentiate that pointer declaration with normal variable declaration simply by preceding that one with star. I hope you all are clear with those concepts what we learned in the last class, like all these things. Okay. So today we'll see about pointer expressions. You already know like what actually an expression is nothing but expression is nothing but a combination of variables and operators. Isn't it or not? We have used the different types of expressions like which is a combination of relational operator, which is a combination of arithmetic operators. All those things we have already learned, and we already learned about how to evaluate an arithmetic expression, all these things. So coming back to here, expression here in this case, pointer expression is nothing but if you are using variables and also your pointer variables in your expression, then that expression is referred to as pointer expressions. Okay, then if you are combining the pointer, if you want to combine pointer variables into your expressions, then what type of operators can be used in your expression, that we'll be going to learn today. Okay, so for your understanding, let me show you some examples which are all the valid pointers. Suppose if we have two pointers P1 and P2 declared like this, then these are all the valid statements. Then how to write these statements, I'll tell you in the future slides. But make a note of this one. These are all the valid pointers like this. We have used a plus operator between two pointers. Observe here. What do you mean by star P1? Star P1 is nothing but a value that is stored at the address which is contained in P1, isn't it or not? So we know star P1 will be pointing to a value, and star P2 is also pointing to a value. So both can be performed an arithmetic operation. So this is a valid statement. Similarly, star operation, because you are performing product, we are trying to find out the product between the two values. Here it is not the address, it is here it is the value. We already learned in the last class, right? So this is one more thing, valid statement, and this is one more thing where for this value you are just adding a 2 value and you are trying to store in the P original value that has been replaced. Got it, all of you? So these are some of the valid statements, that means valid expressions where pointers can be combined. Now, to make you understand how can we write expressions with the pointers, if you observe here, whenever you want to add pointers in your expressions, with pointers, we can have arithmetic expressions only. With pointers, we can have arithmetic expressions only. What do you mean by arithmetic expressions? Arithmetic expression is nothing but in that expression we are going to use arithmetic operators only. That means we have 5 types of arithmetic operators: plus, minus, star, slash, and modulus. So we can use only arithmetic operators with pointers. It is not possible, like we can't use the other type of operators, but only with pointers I'm telling, like P1 and P2 if you're directly using, then we can use only arithmetic operators like this. Then how can we use these arithmetic operators? I'm going to show you. So let us see the first type of arithmetic operation, that is addition arithmetic with pointers. What do you mean addition arithmetic? We want to sum up two values, plus operator. So if you want to use the plus operator, how can we use? We can use that one directly. An address. Address is nothing but, I'll show you one example. An address can be added with a normal number which will result into an address. Address can be used with your increment operator. What do you mean by this one? Address plus plus is nothing but address equal to address plus 1. So if you do like this, address plus plus, then it will give you one more new address. Plus plus address, this is post increment, this is pre increment. If you use one or any one of these two, or if you use both, it will be giving you an address value only. Okay, so all these three statements are your valid statement, but you can't add two addresses, which is an illegal statement. Why we can't add two addresses? Because suppose first address is P1 and second address is P2. Let us consider. We are directly using P1 and P2, not star P1 and star P2. Star P1 stands for the value. P1 stands for the address. Okay. Suppose if you add two addresses P1 and P2, it is illegal. Why? Because your memory is limited, isn't it or not? So whatever memory you have in your system, that is limited. Suppose if you are trying to add two addresses, there may be a chance like you will be getting a value which will be out of bounds of your memory. So whatever memory capacity is there, that is limited. But if you are trying to add two values, always it will give you value, and that higher value may be pointing to a value which is out of bounds of your memory. So to avoid that one, address plus address is not considered, which is invalid. We should not use these things. Okay, so let us start with this first one. What is that one? Address plus number equal to address. What do you mean by this one? Let us understand this with a simple example. So first thing is address plus number. So what do you mean by address plus number is whenever you are giving address plus number, it will give a new address. How you are getting a new address? New address you are getting by adding this old address, whatever address you are giving in your expression, plus symbol is there, plus whatever number you are giving, that number you need to take, that should be multiplied with the size of the data type which the pointer is pointing. So to understand this one, let us take a simple example. Let us take a variable called a, normal variable, and a pointer variable star p. Both are pointing to the integer data type only. Then we can store the address of a in p. This is a valid statement because both the data types are same, right? So p equal to ampersand I am writing. Now what happens if I am trying to write like this? Address is p plus number is 3. I want to get a new address p. Then what will be the value of this one new address? Let me show you with an example. See here. Let us consider the address of A is 2002. That means the value of A, whatever you have given internally, that we are not representing here. The value of A will be stored in the address 2002. Then what happens if you write P equal to ampersand A, then P will be holding the value 2002 only. Isn't it or not? Then what happens if I'm trying to do P equal to P plus 3, then what happens? What is P value? 2002. Consider this formula. 2002, old address is our 2002 plus number is 3 star. I have multiplied with 2. Why I have multiplied with 2? Because we need to consider the size of the data type which pointer is pointing. What is the size of the data type? P is of integer data type which requires 2 bytes, so 2 is to be considered. So if you simplify this one, you will be getting a value of 2008. That means new value, new address, whatever you give. According to this example, your output will be new address equal to 2008. Got it? So this is also a address. That's why whenever to an address, a normal number is added, you will be getting a address only. Okay, this is your address. Is this clear to all of you? Is this clear? The first operation, arithmetic operation, address plus number equal to address. So you make a note of this one, all of you. Address whenever is added. Address in our case it is P. P is holding the address only. So address whenever it is added to a number, that will always give you an address only. And coming to this case, address plus plus. I am not going to take one more example here. Address plus plus is nothing but address plus 1, isn't it or not? That means simply we are adding 1 to that one. You will be getting two address only. Here also address equal to address plus 1 only. So in place of number, you will be adding 1. So here you will be adding 1. The rest of the formula is same. Your old address, and always in this case of address plus plus and plus plus address, the number will be equal to 1. Right? So all these three cases, address plus number, post increment of address and pre-increment of address, will be giving you a new address only that will be generated by using this formula. You should not add two addresses. Why? Because there may be a chance like you will be getting a value which will be out of bounds of your memory. Okay, so this is how addition arithmetic can be used with your pointers. So the next arithmetic operator is different arithmetic pointers. Now, what do you mean by different arithmetic? Difference arithmetic is nothing but we are going to perform a subtraction operation, right? So how to perform the subtraction operation? See here, we can perform subtraction between two addresses. Address minus address equal to number. Address minus number equal to address. We'll understand all these things with examples. We can perform post decrement. We can perform pre-decrement by using with the address. Understand in all these four cases, this one with your addition operation is illegal. That means invalid. But whereas with the difference arithmetic, we can perform subtraction between two addresses, which will not be giving a new address, it will be giving a number. All these four operations are valid operations if you are using difference operator with your pointers. So let us understand one by one. Let us see the first one. What is the first one? Address minus address. Observe here, it is giving you a number. It is giving you an integer number. It will not give you a new address. What do you mean by that one is, we'll see. So how it will be performing this address minus address is, let us consider two addresses, address 2 and address 1, that is P2 and P1 let us consider. Then it will perform simple subtraction between the two addresses, and that will be divided by the size of the data type which the pointer is pointing. Okay, that means P1 minus P2 by the data type size, whatever the pointer is pointing, we need to divide with that. So how it will be done? Let us consider one example. Let us see int a, b, and I am taking 2 pointer variables because we are trying to perform the subtraction operation. I will be taking 2 variables and 2 pointers. So P1 will be holding the address of A, P2 will be holding the address. Now I am trying to find out P1 minus P2. That will always give you one value, and that value will be of integer data type. That's why difference is declared as int. Now, if you write like this, and if you are trying to display the address, here it is percentage %d. Make a note of this one out of the percentage %d. This difference is not an address; it is a percentage %d. Okay. Now, whenever you write like this, what happens? Let us see the example. Let us consider A is stored in the location of 1004 and B is stored in the location of 1000. And then if you are writing P1 equal to ampersand A, then address of A will be stored in P1 and address of B will be stored in P2 if you are writing this statement. Now we are trying to perform the difference P1 minus P2. Then what happens? Take this formula. What is that formula? We need to perform the subtraction between the two addresses, that is 1004 minus 1000 by, we need to take the size of the data type, that is integer data type, which is of 2 bytes. We need to take that one too. So if you do this, simplify this one, you will be getting a new value, which is a number. This is not the address. That's why it is given here. When you are performing address minus address, you will be getting a number, not a new address. So the output of this program will be new address. Sorry, it is not new address, new value. Let me change this one so that you can move on this one. So you can see this I have modified this one. We will be getting a difference value, and that difference value will be always of data type. That's why I've declared that one as integer. So you will be getting a value of 2 according to this example. Got it? Now if you observe here, address minus address is always giving you a number, and that number is called as offset. Always remember, what do you mean by an offset? Offset gives the difference between the two addresses. What do you mean by that one? That means the number of values that are stored between, like the difference, the number of locations between these two addresses. Got it? So address minus address always gives you a number, and that number is always referred as offset. So whenever you are asked to define what is an offset, offset is nothing but the difference between the two addresses. And how the difference will be calculated? The difference will be calculated by subtracting the two values by the data type of pointer variable. Right? So this is your first one. What is that one? Address minus address equal to number. Is this clear, all of you? Note down this one. Okay, we'll see the next one, that is address minus number. So we'll see this one, address minus number will give you a address. Same like your address plus number which has given a new address. Similarly, address minus number is also giving you a new address. The approach is just we need to we need to take the old address, we need to perform the subtraction operation, and this number should be multiplied with the size of the pointer, size of the data type of the pointer, what it is pointing. Same like your addition arithmetic. What we have to do here, let us consider int a and star p. P is holding the address of a, and we are trying to perform p minus 3. Then what happens? If you take here, you will be getting a new address. So let us consider the address of a is 2002. Then p will be holding that address only. And p minus 3, if you are trying to do, then 2002 minus the number is 3 star. The data type of p is 2, so it will be multiplied with 2. You will be getting a value of 1996. Okay, so you will be getting an output of new address equal to 1996. So observe here, whenever you are trying to perform a subtraction operation, you will be getting a new address only. Same like your addition arithmetic. And similarly, address minus minus and minus minus address is nothing but your number here. You need to use the same formula where the number will be 1. Got it? So old address, whatever address you give, old address minus 1 star size of your data type, whichever it is pointing to. Suppose it is pointing to float, then the value here it will be 4. If it is pointing to char, then the value will be 1, like that. Got it? So this is the way how we need to use a difference arithmetic. That means subtraction operation between the pointers. Understood all of you? Is this clear to you all? The next, so we can see here only these operations can be performed by using our pointers. That means addition with a number, addition plus plus, plus plus addition, subtraction minus number, subtraction minus pointer minus number, pointer minus pointer, minus minus pointer, and pointer minus minus. These operations are only allowed in your C programming language with your pointers. So let us highlight what are all allowed in our C language. So if the number is greater than the address, what do you mean by that one? That means if P1 address is smaller than the P2 address, it will take the, that means what we can say, the difference value, it may be a negative or a positive value, it will be taken as a positive value. Okay, so addition of an integer to a pointer is possible. That is what add address plus number is possible. Subtraction of an integer from a pointer is possible. That means address minus number is possible, and subtraction one pointer from the another is also possible. That means we have done address minus address. So these three are valid, which we have seen in your earlier slides. Okay, but which are not allowed. Make a note of this, all of you. I already told you. Two addresses can't be added because you may get a value which may be out of bounds of your address. So two pointers can be added, and multiplication and division operation can't be used in your pointer expression. That means two addresses can't be multiplied. An address can't be multiplied with a number. An address can't be divided with a number. An address can't be divided with an address. Address can't be perform a modulus operation with your other address. All these operations, whatever I have highlighted here, are invalid operations. Only these operations which we have learned in our earlier slides are valid slides. These operations are invalid operations. To understand this one, I'll show you some examples. P2 by 5. You can't perform a division operation on a pointer variable, which is invalid. And also you can't perform a subtraction operation. You can't perform a multiplication operation, P2 star 10. If you see here, this is not possible, which is invalid operation. So these operations which I have highlighted here, 5 types of operations, these 5 operations are not possible with your pointer expressions. Only we can perform these operations. Only these 3 operations can be done, which we have already learned with the example. Got it? So note down this one, all of you. So this is all about your pointer arithmetic. So how an arithmetic operations can be performed by using your pointers. Only pointers like P we are talking about, which is holding an address. Okay, we have already highlighted what are all the different types of valid operators we can use and what are all the invalid operators we can use. I hope you all are clear with this concept. Okay.